So here's a sketch generated by technology of exactly the thing that's up here on the board, right? A normal distribution curve whose mean, the middle, is 43,000, whose standard deviation is 22,000. So you'll notice that on this axis down here, that 22,000 is what separates these two tick marks from one another, 22,000. And we've shaded a region that has an area of 15%. Up here on the top. So this is the general setup of what we're looking at. And what we need to know is what value of x exists right at this boundary here, which separates the 15% of probability to the right, 0.15, from the 85% of probability to the left, 0.85. So we just need to know, what is that dividing line? How do we use the table to find that? Let's bring up our z table here. And just a quick word about how to use the z table, because this is also where people sometimes get twisted up into knots. So on the z table that you use in this class, there's a kind of a first row and a first column that are important. What kinds of numbers do you find on the first row and the first column? What do those represent in this table? Say again? The numbers highlighted in green, what role do those play here? What kinds of numbers? Yeah, so the numbers on the outside here are z-scores. So we can either plug in a z-score to this table, or we can ask this table for a z-score. If that's the numbers on the outside, what do the numbers on the inside represent? So all of these. Yeah, all of these numbers on the inside represent percentages or probabilities. And because both of those start with p, sometimes these are called p-values. Percentages, probabilities. And so we can use this table to go one way or the other. Either we can feed this table a percentage and ask it for a z-score, or we can feed it a z-score and ask it for a percentage. That corresponds to the two different problem types. In the first problem type, where we know the value of the variable and we need a percentage, we would be going from z-score to probability. In other words, from the outside of the table to the inside of the table. For problem type 2, where we know the percentage and we want the value, we're going from percentages to z-scores. And so we're going from the inside of the table to the outside of the table. In our example, which way do you want to go? What do we know and what are we looking for? Say again? So we're looking for x at the end of the day. We can't get there yet because this table doesn't have x's. It does have z's. So finding z is an intermediate step to finding x. But we can't find z unless we know what? The percentage, the probability. And in this table, what percentage do I want to ask for if I'm looking for where that 15% right tail is? What percentage am I going to use? That's the 85%. And again, the reason that we use 85% in this table is because the way that the table works is that the table gives us the left-hand probabilities. The table does not give us the right-hand probabilities. So always make sure you know how your table works before you use it, right? Because the table is giving us left-hand probabilities, it's the 85% that we want to look up, and not the 15%. That's why it pays to label all regions of your graph before you go to use the table, because in the table that you use in this class is constructed around these left tails. So I need to find the number 0.85. Where should I look for it? So I guess my question is, do I want to look for it in the green numbers or do I want to look for it in the orange numbers? Green? Can we take a vote? Who wants to look for it in the greens? A couple hands. Who wants to look for 0.85 in the oranges? Okay, the orange majority rules here. So why are we looking for 0.85 in the orange numbers? Because we don't have a z-score. What is 0.85? What kind of number? We don't know the z-score. What we do know is a probability. So where we should be hunting for 0.85 is inside the middle of this table. So we'll just look down the rows, look down the columns until we get to one that's close to 0.85. And I seem to have found one. So we look for 0.85 in the middle because 0.85 is playing the role of a probability, not a z-score. Which one of these two do you want to choose, by the way? Yeah, let's choose the one on the right. It's a little bit closer. There are some that believe we should try to like split the difference and go in between the two of them, but let's just pick the closest one. Okay, 0.8508. So we found that. That's our probability. So now how do we get a z-score out of that? All right, so we look to the left to get the first couple digits of that number, and we find that those first couple digits are 1.0. And then what else do we do? Yeah, we can look up to find the hundredths digit, the next significant figure. So what is the z-score that we find using this method? All right, 1.04. So we just used the table to convert a percentage into a z-score by looking in the middle for the p-value and then going to the outsides to find the z-score. What does the z-score tell us, by the way, about personal incomes? Can we put this into a sentence? I'll get you started on the sentence. In order to be in the top 15% of personal income, you must what? What does that 1.04 tell us? Anyone know what z-values actually represent? So how I like to think about z-values is they're a measuring stick. They tell us how far away we are from the mean, but not in dollars, as we would expect in this example, but it tells us in numbers of standard deviations. So how I would complete this sentence is to say, in order to be in the top 15%, you must have an income that is at least 1.04 standard deviations above the mean. Above the mean. So that's what a z-value represents. How far away from the mean are we, measured in numbers of standard deviations? So 1.04 means 1.04 standard deviations above the mean. Believe it or not, even though I'm a mathematician, I'm not a huge believer in formula all the time. Let's see if we can take the sentence that's written up here on the screen and use that sentence to stand in for this formula. So I want to know what income is 1.04 standard deviations above the mean. Well, first of all, what is the mean in this problem? 43,000. So why don't we just replace the mean here with 43,000? Okay. And what is the standard deviation? So let's replace this standard deviation here with 22,000. So I'm looking for an income level that is at least $22,000 above $43,000. What kind of arithmetic am I doing if I'm using the word above? What operation does that sound like? Yeah, it sounds like addition. And if I want 1.04 numbers of standard deviations, what operation is going to connect that 1.04 with the 22,000? Yeah, there we go. And so the income level that I'm looking for is 1.04 standard deviations, or 1.04 times 22,000, added to the mean, which is 43,000. So all we need to do is just follow the order of operations. What operation do we do first here? Multiplication. PEMDAS. M comes before A. So 1.04 times 22,000 is 22,880. I think that's right. You'll have to double check me. I'm working on the fly here. And then I'm supposed to add that to 43,000. And that's going to give me 65,880. And there's my x value. If you're a believer in formula, if you're looking for a way to automatize that process, we can take the formula for z-score and just rearrange it to solve it for x. So sometimes if people make up formula sheets, they'll also add this formula to the sheet also. If I solve this equation for x, we're going to do the same steps that we just did over here with the order of operations. First, we're going to multiply by the standard deviation, then we're going to add the mean. If I do that on both sides of the equation here, multiply by the standard deviation is going to turn the circle with a hair on it to the left side. And then adding the mean is going to move the u with the curly tail over to the left side also. And then just to make the formula look neater, we'll just move that to the right side. So mu plus sigma z. So we could have just used that formula, but I kind of like this way of doing it over here because it helps us to remember what the formula means and why it works. So we found out that if the mean personal income is $43,000 and the standard deviation of that personal income is $22,000, then in order to be in the top 15%, we need to be making at least $65,880 per year.